All right, well, welcome everyone. This is another exciting Learning Lab. This is Learning Lab number 60, a special installment, and this one's on time series. So every now and then what I'm doing is I'm switching things up a little bit, and I'm gonna mix in some time series as I'm making more developments and some progress, and the community members are making more developments in the model time ecosystem. So we'll be talking a lot about this package today here, which is called Model Time. It is an ecosystem of packages that are being developed by me and others in the community, and it's growing. We'll be primarily focusing on gluonts and Torch today, but we're also going to be talking about some new features just in the general Model Time package. Okay, so we'll get started here. The goal for today. We're going to learn about some new tools that can improve our forecasting. We're going to be working with a difficult data set. So if you can see here, it's got, this is actually airline passenger traffic. And you can see that there's a big drop here because of COVID-19. So we're going to be working with this data set today. It's going to be a little bit of a challenge. And this is, like many industries, probably airlines and have been impacted the worst because of COVID. Them along with retail, the retail sector have also been impacted. So this will be a nice challenging problem for us, a good one for us to test out some of our model time capabilities. Okay, if you aren't familiar with Learning Labs Pro, this is a lesson that's being recorded. It's going to go in our special time series section. So there's a special here. We have other time series forecasting lessons as well. They're all around model time and the growing ecosystem. They talk about things like hierarchical forecasting, model time gluonts, the deep learning. We'll also talk about that in here today. Autoregressive machine learning, forecasting at scale, and just a general introduction to model time. I'm going to put the link in the chat so everyone, if you are interested, if you want the code for today, if you want any of the bonuses that we give away, check out Learning Labs Pro. It's a very convenient and easy way to access all this content on demand. Just a little bit more here. There's all sorts of different labs in Learning Labs Pro, 50 plus labs. Actually, this is the 60th. So we now have 60 labs. These are basically like mini courses, 1-hour courses, quick bursts of information on specific topics and in different sections like tidymodels, marketing, and so on. There's lots of bonuses that I give away, and we talk about all sorts of different topics that are important to data science. Some of the bonuses that I've given away in the past, we've got just in the past few lessons, a bunch of shiny apps, customer retention app, hierarchical forecasting app, loan default scoring app, and more. So these are all sorts of bonuses. Check out the program. All right, the business problem for today. We're going to be focusing on airline passenger forecasting. So So we know that COVID-19 is having a big impact across many different industries. Probably none has been more impacted than the airline industry. So this little thing here, this is a particle of COVID-19, and it's having a massive impact on all sorts of different industries, creating all sorts of health issues, and it's just a global pandemic. So what's happened with specific industries is we can see that in their data that certain industries were affected, airlines being one of the most, also retail sales has been quite affected as well. So what we're going to be focusing on is this COVID analysis, where we're going to see a big dip in the data today. So in April 2020, domestic travel in the United States was forced to shut down, and as the US took action to prevent the spread of COVID-19. And you can see this big dip here in the data. So this is for American Airlines. We have Delta Airlines, Southwest Airlines, and United Airlines. These are 4 of the biggest domestic airline in the US. So as of 2021, so we're a year after this, we can see that most major airlines are still in the recovery mode. So they're reporting under 50% of the passenger loads of the pre-COVID-19 pandemic shutdown in April 2020. So this is over a year later. So we're going to be focusing on trying to forecast the next 6 months of air travel, so June through November of 2021. And this data is updated. I just pulled it down yesterday. from the Bureau of Transportation Statistics. So I got the data here, and that's what we're going to be doing. That's the challenge today. Okay, so let's talk about model time. We want to know what this, if you've never heard of model time before, if you're brand new to time series forecasting, I want to talk about this package that I developed in this ecosystem and how it's growing. So it is a growing system of forecasting tools. The reason I developed it is because businesses are going through a massive shift right now. They have a lot more data. It's more granular. So think of products and customers or different regions and different stores in different regions. So we have massive data sets now, and we have to be able to forecast at a granular level because granular is the most accurate, and that's what the businesses are demanding. So in the past, it used to be okay to just forecast, top level sales, like, hey, our revenue is going to be this for the next month, or maybe the North, West, South, and East regions are going to be this for this month. Now we have to forecast for product X. We're expecting this demand over the next month or 2 months. And that is placing big strains on data science departments because they're not able to handle this amount of data and the forecast frequency and the amount of forecasts that they have to produce. It's literally thousands and thousands and thousands of forecasts, some cases millions of forecasts for really large companies. And this has to be done every day or every week. So what I'm talking about with scale is basically this, where we have a lot of different forecasts, and this is a different data set. This is actually the web pages on my website for business science. And you can see the homepage traffic is here, and we're making some forecasts over the next several periods. So think of this times 1,000. So if a business has thousands of web pages, they need to make those forecasts, and they want to understand which ones are upticking, which ones are changing. So this is where model time comes into play. This is really model time's strong suit. So what is model time? It's an ecosystem that is developing. It's actually started out as an R package. So this package right here, I developed it for forecasting. And the key idea that I wanted to start beginning to use is that no one had taken this kind of suite of tools called tidymodels, which is very similar. If you're familiar with Python, scikit-learn, tidymodels is like the equivalent in R. And what I wanted to do is be able to use this tidymodels ecosystem to be able to forecast, because I saw a lot of the different data science competitions that focused on time series, on Kaggle. They were all using machine learning algorithms, and no one was doing that. So before model time, it was primarily the forecast package. Now there's several other packages available, but model time is the only one that focuses on this machine learning aspect in R. And it's the only one that focuses on panel data in either R or Python. We'll talk about that more here in a second. It integrates at a high level, integrates many different packages. So ARIMA from the forecast library, Profit from the Profit package, tidymodels ecosystem, and many time series algorithms. It's a growing ecosystem too. So it started out as just one package, but as it grew and as I needed more features and benefits, I started to grow it. So there's more packages like backtesting, ensembling, which is a competition winning solution. Deep learning, we'll talk about this one today, modeltime.gluonts. And then one of the newer ones is H2O AutoML. It's for automated machine learning, and we've integrated that now into the time series system. So back to model time, it's been developed for scale. What I saw out there is that there's no time series packages that focus on this concept of global models. I'll talk more about that in a second. So model time is different from all of these other forecasting frameworks in Python and R. So in R, you have Fable, you also have the forecast package, and in Python, you have SK-time, which is is one of the time series frameworks. These are very good tools, but they focus on a different problem, which is iterative forecasting. Every time series, you run through a for loop, and you basically produce a single model for each time series. That's the problem with that approach is it works really well and works really accurate, but it can take days, if not weeks, to perform it on a large time series database, such as those that most companies have. So if your company has, say, 2,000 customers, that means you have to make 2,000 different models, and each model takes, several seconds. And if you want to make lots of models and try and decide which one, it really becomes a scalability nightmare. So model time focuses on rapid experimentation, giving you access to lots of models, but you build basically one model for the global time series. Now you can do iterative as well, and that's actually on our roadmap, but I'm going to focus on global modeling today with what's called panel data. Again, we'll explain more about these concepts later. Now I really want to focus though on all the cool things that Model Time does. So Model Time has lots of models available. It integrates things like Profit, the forecast library, gluonts. It now integrates PyTorch, H2O AI. It integrates all of these things. And we have lots of models available. So for those of you who like to experiment, and I will tell you this, competitions are won by experimentation. Don't fall in love with a single modeling approach like ARIMA. Try a bunch of different ones and see which one works the best. So that's what Model Time's built for. So Model Time, for example, has all these different functions, and they integrate. So Profit Reg integrates Profit. ARIMA Reg integrates Auto ARIMA and ARIMA from the forecast library. Exponential Smoothing integrates ETS, Croston, and Theta from the forecast library. Seasonal Reg integrates TBATS, STLM. Neural nets, so neural net AR from the forecast package is integrated with this function. I have my own homegrown forecasting functions. This one's called Profit XG Boost. It's based on a competition winning solution where I saw that they use XG Boost errors to improve model performance. I did the same thing for ARIMA. I created Auto ARIMA XG Boost and ARIMA XG Boost. There's window reg functions. We'll actually be using these today. So this is kind of a baseline tool. Talk more about that in a second. And then there's another baseline called naive reg, which gives us access to naive and seasonal naive. So if you want the full algorithm list, I'm going to just click on this, open this link in a new tab, and you can explore the algorithms right here. So I'll put that into the chat window, and you guys are welcome to check it out. These are all available inside of the Model Time, just the base Model Time package. Okay, next, we've got even more models available. So we'll be experimenting with several of these today. We've got the gluonts Deep AR. So this is the gluonts package. It also has its own algorithms list. And again, I'm going to put this into the chat. So open this link in a new window. I'm going to put this in the chat here. And these are all of the algorithms right here that I'm going to be talking about. So we've got gluonts Deep AR, which links to both the gluonts Deep AR and then the new Torch Deep AR back end, which is something that the people at Amazon, so gluonts is a package. Gluonts is built by Amazon, and Model Time integrates it into R. So the people at Amazon have now integrated Torch into their gluonts framework, which means we can now access it. So I've just updated the Model Time version to now include that. Very exciting stuff. It includes NBeats, Deep State, and now GP Forecaster. These are two new algorithms that I've just recently added in. So check those out. We'll be demoing those today. And there's way more models that it integrates. So lots of models available. And basically anything that is compatible with tidymodels, it can integrate into Model Time. So that's like XG Boost. I use that a ton. Decision trees, GAMs, which are now available in Parsnip, which is one of the tidymodels libraries. Linear regression, Mars, neural networks, k-nearest neighbors, random forest, support vector machines, and many more algorithms. And I'll put this link into the chat. Open this link in a new tab. This is the list of Parsnip libraries. Okay. And then I saw a question over here by Harlan. What about Bayesian dynamic time series? I'll get to that here in a second. Community contributed Model Time extensions. So it's now beyond me. It's not just business science that is creating these packages, but others out there in the community are creating these. So there's now a boost time package, which integrates both light GM. So it's basically Profit boost instead of XG boost. They're swapping out light GBM and they're swapping out with cat boost. So check out the boost time package. That's by one of my students, Alberto Almunia, and he is creating several, like 3 of these different packages. Bayes models, which for the person who just asked about Bayesian dynamic time series, check out Bayes models. There's also Garch models that Alberto has created. And then also there's this SK Knife Data R. This is built around the idea of iterative. So kind of the things that like Fable and SK Time do, which is one after another, go through each time series, model them individually. That's what SK Knife Data R has some capabilities to do too. And I will say this, we have a growing ecosystem. We also have a roadmap where we're going to be adding even more algorithms, and we're going to be adding even more capabilities into the model time ecosystem. So I'm pretty pumped up about it, if you can't tell. Okay, so I'm going to talk about some of the changes, the recent additions to model time ecosystem that we're going to be focusing on. There's this idea of a global model. So I first found out about this back when I was doing research for my time series course. And what I found is that these competition winning solutions, especially in the M5 competition, which is one of the more recent data sets, it was a daily data set, lots of time series. I think it was a hierarchical data set where it was actually Walmart sales data for several of their stores and departments. In those stores, they had at the product level all of these different products that were being asked to be forecasted. And some of the winning solutions used techniques like Deep AR from GluonTS TS. They also use XG Boost, or actually Light GBM, which is basically a very similar algorithm. And they built these global models that were able to forecast all of the time series. And this is exactly what I wanted to integrate into model time, because I saw how effective it was, but also how scalable it was. So for Walmart, who has millions of time series, and then in this competition, they're dealing with hundreds of thousands of time series, being able to build one model that forecasts all of them is a big advantage in speed and being able to tune it and be able to get it to be able to work very well for that scale of data. So what I'm talking about here is if, say, for example, we have 1,000 time series, and you can see that there's usually an ID column, there's a date, and then there's a target, and then there might be some external regressors or extra, we call these X-regs. They're just regressors. So like an event like New Year's Day, you might flag that as a 1 or a 0. But we'll basically be focusing on the fact that there's an ID that separates each time series in your table. There's a date for each of the time series. There's a value for those, and that value is what you're trying to predict. And then these are optional. There may be extra regressors. What you do is you then create one deep AR model or XG Boost model or so on, and it models all the data at once. And the advantage here is that you don't have to loop through each one of these time series individually, creating separate models. It's very fast. So, and this is an example of what I did on a different data set with, and this is a kind of a store sales example where we had 7 stores, and we predicted using just one model, actually 2 different models, the Deep AR Torch and Deep AR, and kind of showed, how they would predict on these, on all of these time series at once. So it's a global model. The key idea here is you just make one model, it predicts all of your time series. So if you understand that concept, that's what we're going to be focusing on today. Some of the new features that I've built around this idea of global modeling. So this is some of the news from time series or from model time. So I'll just open this link in a new tab. Here you can get the full news, all of the changes that we've been making just to model time here. I'm going to paste that in. And this is the news that, so these are some of the changes that have been going on in model time. One of the key changes we'll be focusing on today is the idea that we can now get local accuracy and confidence intervals from global models. So before we were limited to just global accuracy, so you'd only get like one accuracy, but now you can get accuracy at the time series level. So if you have 1,000 time series, you can get 1,000 accuracy estimates for each of those, one for that for that global model for each one of those time series. So I make it really easy to do that. Same thing with confidence intervals. It'll adjust the confidence intervals if you want local or global. As of model time 6, so I released this several months back, I added hyperparameter tuning and workflow set integration and also parallel processing integration. So this is a big performance booster. We now have parallel processing and we have some easier ways to do hyperparameter tuning. I'm going to show that off today. And then as of model time 04.2, I've added in global baseline algorithms. So these are window rig and naive rig. You may be asking why is that important? Why do I need a baseline algorithm? So what a baseline is it's something that you compare your model performance to. So your organization normally wants to know, okay, you're predicting with XGBoost and, this is great, but like how much better is it than if I just predicted, a 3-month moving average? Now you can do that with window reg and with naive reg. And also, a further reason that you want to be able to use this is these are super simple algorithms that are scalable. And the thing is that especially like in times of big change, like with COVID, sometimes the simplest algorithms work better than the more sophisticated algorithms. We'll see that in this case, where it turns out that just predicting the last data point and predicting that forward for the next 6 months is actually a pretty good solution. And I'll show you how to tune this window rig in order to find, which windows to use. And then just one other point, in the M5 competition, I believe it was the 72-week median. So they take the last 72 or the last 72 days, and they just take the median and schedule and forecast that forward. That was one of the highest weighted solutions for a long time. So it's actually pretty powerful. And we'll see that today. It actually does a decent job. So we talked about model time. So now we have model time gluonts. Some of the new features that we're going to be focusing on here is gluonts, which is the Python library, has recently been upgraded to 0.80. And what they did was they integrated PyTorch into that. So what I said is, okay, this is great. I want to integrate that PyTorch now into model time gluonts. So I've updated it. I've added a new torch engine that we're going to take advantage of today. It's very fast. It's about 30% faster to perform these analysis. And in some cases, it's even more accurate than the gluonts version. I've also integrated GP Forecaster, which was a student request. In the deep state library or the deep state estimator, I've integrated that. So these are some of the awesome new features we're going to be checking out today. All right, so let's get going. For my LL Pro members, this is the project that we're going to be doing today. We're going to spend about 30 minutes going through around 400 lines of code. It'll go pretty fast though, because some of it's repeated. But we're going to be focusing on several different concepts. The first one is the new models. The second one is the new features, the model time workflow. Third one is the hyperparameter tuning, new features. And then the fourth one is these global baseline algorithms. And we're going to show you how to make a final forecast, selecting the best by ID, and then an alternate final forecasting, actually using another package called Model Time Ensemble. So there's a lot baked into this lab. If you get this under control, meaning you know it, you're going to be a serious weapon to your organization. I'm telling you that. All right. So the project, we're basically just working out of this script today. There is some data sets in here. I downloaded the American Airlines, Delta Airlines, Southwest Airlines, and United Airlines as CSV files. We'll be reading those in. So we'll get started. We've got a lot to cover. The main thing here is, and I know some people are gonna have challenges because of the gluonts. So model time gluonts requires Python to be set up. I have installation instructions right here. So if you guys want to check this out, this will walk you through exactly how to set up model time gluonts. And it's just been updated. I've actually worked through a ton of GitHub issues with Windows people because they had the biggest issues getting the model time gluonts 080 upgrade installed. And we've now worked through all of that. So it should be easy to install for you. To install Model Time Gluon TS, you are going to run this line of code here. It's remotes install GitHub business-science Model Time Gluon TS. The Model Time Gluon TS package on CRAN is not good. So don't use it. It hasn't been updated since version 0.10, and that's because I'm having some challenges with the fact that it uses reticulate and getting CRAN to accept some of the tests that I run and everything. But I test it fully, and trust me, it's a very good package. And if you want it, you'll definitely it's really powerful. Once you run that first line of code, then what you're going to do is you're going to run this function called install gluon TS. And what I'm going to do is you can install, do a fresh install. So if you've ever previously installed a version, what if you change fresh install to true, that's going to delete your previous version of the Python gluon TS library, and it's going to install a new Python gluon TS library in there. And then if you include PyTorch, we want to change that to true. So I'm going to do true here because we need PyTorch for this lesson. Now I'm not going to run this because I already have everything installed, but when you run that, what it'll do is it'll install Gluon TS, the Python environment that is needed for Model Time Gluon TS to work. So once you get that all straightened out, just run through these installation instructions and run these 2 lines of code. You should be good to go. You want to do a session restart R, and what that'll do is kind of freshen everything up and allow R to recognize that you've got this new environment available that Model Time Gluon TS will be able to connect to. So once you refresh your session, we're going to load some libraries: tidymodels, workflowsets, Model Time Gluon TS, Model Time Ensemble, Time TK. So this is the tidymodels ecosystem. This is my Model Time series ecosystem, which extends tidymodels for forecasting. And then the last ones, tidyverse, lubridate, and janitor. These are just kind of some core libraries that I use a lot. You want to run this next line of code, reticulate PyDiscover config, and make sure that you have your rgluon-ts activated. So what if this shows something different, you know that there's a problem. Probably what you need to do is, so when you load Model Time Gluon TS, it'll automatically connect to this. If you didn't run the session restart R, then you just need to likely restart R and rerun these lines of code from here down, assuming you've installed Gluon TS already. Okay, and once you get that, you are good to go. So we're going to go through the first section here. We're going to import our data. So this is cool, and a new kind of feature of readr is it can read all 4 of these at once, and it's super fast. So what I'm doing is I'm going to get some file paths. These are the file paths in my data folder for anything that ends with CSV. So that's what I'm doing right here. And then what I'm doing is read CSV, my file paths. I'm giving them an ID of path, and I'm telling it name repair to use janitor make clean names. When you run this is really cool. Look how fast it just read in all 4 of these. And it's picking a delimiter of a comma, and it's basically telling us that it loaded it in. If we check out the data, it's loaded all 4, and it's put the path to that file in this path column here that I told it to here for the ID. And then it's got the year, month. Month is a character because it has some of the totals in here. And then it's got domestic, international, and total travel. So there's domestic is inside the US, internationally is outside of the US, and then total is just the sum of domestic and international. So that's the data. Next, what we're going to do is clean this data. So we'll start with the data. We're going to remove anything with total in it because we don't need a total, which is just the yearly total. So we're going to remove that. So now all the totals are out of the month column. We're going to add a date column here. So we're taking the year and the month and converting that to a date. Then what I'm doing is I'm taking this carrier path, and I'm going to create a new column called carrier, where it just extracts out this American Airlines and formats it. So when I do this line of scripts here, just a little bit of data wrangling here with some text. Now I've got the American Airlines and title case, and it looks a lot better. Next, what I'm doing is I'm just going to select the columns that I care about. So I'm going to select carrier, date, and then everything from domestic to total. So we'll just do Control Enter. It looks something like this now: carrier, date, travel type. Oh, I did the pivot longer too. Whoops. That's the next step. So pivot longer, what I'm going to do is I'm going to pivot the domestic, international, and total. So they're all stacked on top of each other. And I converted it to a column of travel type and value. So you can see that the number of rows just grew. It was 892 and now it's 2676, so roughly 3 times as large because we took these 3 columns and stacked them on top of each other. The next, we're dropping any NAs. So this removes a couple of values of NAs that are in there. And then we're going to create an ID column, which will be my time series ID. And what that's going to be, so this ID column here is going to be the combination of carrier and travel type. And then I'm going to select the ID, date, and value. So when I run all of this, now I should have airline data table that is in a good format. So we've got the ID, so American Airlines domestic, American Airlines international, American Airlines total, and that's for each of these first dates here. And then once it moves to the next month, it's the same thing, 3 things repeated. And we have that for every single airline for domestic, international, and total. So now we're kind of formatting it into this shape of what's called panel data. And that just means that all of that data is in there with an ID, a timestamp, and a value. So we'll visualize it next, and I'll see an issue here. So one of the issues, I'm using this plot time series function from my time TK package. And one of the issues that I saw is that if I run this next line of code here, these TK summary diagnostics, some of these don't all end on the same date. So 210401 is the longest. So that's this domestic travel. And for whatever reason, we don't have the international and the total numbers past 101. So what I'm going to elect to do is I'm just going to select the domestic travel, and we're going to be modeling that. So it's going to be these 4 time series here: American Airlines domestic, Delta Airlines, Southwest Airlines, and United Airlines, all domestic. So when I do that, I'm going to replot it, and we'll just be focusing in on these 4 time series for this analysis approach. Now, if I wanted to model the other 2, what I could do is I could model this domestic first, and then use this as a regressor to help fill in the data that's missing for the other 2. Okay. So now we're into the first section here, new model. So we've got our data prepared. We're ready to start doing some modeling. And I want to check out my modeltime.gluonts package. You need version 3 or greater for this to work. So what I'm first going to do is I'm going to create some splits. And what it's going to do is it's going to take all of those time series and basically take this last window here, and it's going to use the last 6 observations as my assessment, and then all of the previous observations as the training data. Once I create these splits, the splits object, so we can see it's 868, 24, and 892 for the total. So there's 868 training observations, 24 testing observations. So that's 4 times 6 is 24 because we have 4 time series. And then 892 total. So that's just 868 plus 24 is 892. All right, so let's first talk about Deep AR. This is the existing engine. So this is just this is nothing new beyond what I've included. This has been available for quite some time. In fact, I teach it in the time series course. So it's one of the first algorithms that I've integrated on the deep learning end, and it's really good. So I'm going to run it. Basically what I'm doing is I'm telling it that the ID feature in my columns is going to separate each of these IDs. So again, it's a panel data, a global model, one model it's producing for all the time series. It's a monthly frequency, we're predicting the next 6 observations, and we're taking a look back length, and I shortened this because I don't want it to look back too long. So we're looking back 3 periods, and the reason is because if you look back too long, it'll start thinking that this is the general trend, whereas I want it to more focus in on the local trend. I'm telling it to do 10 epochs. You can crank this up as much as you want. And if you have GPUs, you can set up model time to work on the GPUs, so you can really crank this up. And the model's done. So we've done our 10 epochs. We can see that what I look at here is the loss. So the average epoch loss is down to about 14.2, and we now have a deep AR gluonts model. Okay, so nothing new there. What's cool though is that in model time, or in gluonts 0.8.0 in Python, they have now integrated Torch. So if you've installed PyTorch with this installation script where we have include PyTorch equals true, what that'll do is it'll install the necessary packages, and then you're good to go to run this next section of code. The only thing that's really different here from this previous gluonts is I'm actually increasing, I'm doubling the epochs because this is even faster. And I'm switching out the engine from, it was gluonts deep AR, now it's just Torch. So I'm going to run this, and we'll see how fast. So now we're doing PyTorch, and what it's doing is it's really fast. I mean, we're seeing that the training loss is right here, 14.8, 14.7, and so on. And it's just kind of like lightning fast going through. It's generally, I've done some tests, it's about, we'll say 30 to 40% faster in doing epochs. So if you've ever done deep learning before, generally as you increase epochs, it tends to do better. So doing double the amount of epochs, and you can see it's already done. Okay, cool. So we now have our deep AR Torch model created. The output looks very similar. So you can see, but it is different. It's actually deep AR Torch, and it's a Torch model. Okay. The next one is, this is also new. I just added this in the model time gluonts. It's the GP forecaster. This was a request of one of our students, and I've added it in. So what I'm doing is I'm using a different function here. I'm changing, I took off the look back length to try and decrease the loss. Now we can see that this probably isn't going to be very good because our losses are so high compared to what our deep AR loss was. So that's just kind of an indicator there. It's probably not going to be that great of a model, but I will tell you this, just because it doesn't do as well on this particular problem doesn't mean that it's not a really good model, because I've tried it on other problems and it's actually beat deep AR in some. So you need to experiment. And this is one of the reasons that model time is so powerful. Create all of these different models. We're going to do the deep state next. So we're doing the deep state function, basically keeping kind of consistent, setting the engine to gluonts deep state. And we're going to run this, and it's going to fit that data set. And once it's done, it's going to pop out a model. So it should go through pretty quickly here. And I do have it set up to do 20 epochs. So you can see we're down around 14.4 average loss, 14.2, and so on. We want to see that continue to decrease, and hopefully it does. Once we're finished with that, what we're going to do is we're going to check out the second of the new features. So you're seeing the gluonts deep learning now. What we're going to be doing next is checking out this model time workflow, but we're now going to be doing this thing by ID, which is really cool. It's been one of the big requests that I've gotten from a lot of my students. Okay, so now our deep state model is produced. Okay, so once we do that, what we're going to do is we're going to make a model time table. And this just kind of organizes our models, and it gives it a description and a model ID. And then what we're going to do is we're going to calibrate it. So what I'm doing is I'm actually taking the testing data and I'm telling it to predict on that testing data. So that region over here that's red, I'm making it predict on that. And then once we get that, we get this calib-gluonts tibble, and it has the model time table, and it also has the calibration data here. So it's going to store that, and that's going to be kind of what we use to assess our accuracy. All right, so next what I'm going to do is I'm just going to do the normal workflow first before I show the improvements that I've made. So I rewrote this function model time accuracy. So the defaults are still the same. When you call model time accuracy, it's going to produce the mean absolute error, the MAPE, MACE, SMAPE, RMSE, and R squared for your test data set. And this is just a global, what we call a global accuracy measurement. It means for all 4 of those time series combined, this is what your average error is here. This is what your average RMSE is here. And that may or may not be good, because if some of your time series are very low. So for example, this one, is like 10 million. Some of these other ones are only in like the 6 million range. So your error on this time series is going to dominate these metrics. So basically, if your model does well on this, it's going to have good metrics, but it may not be performing as well on these, and that's an issue. So what I've done is I rewrote this model time accuracy now to, and what I did up here is I added this in the model time calibrate step. I added this ID equals ID. And that basically tells us that, hey, we want to key in on an ID here when we do our calibration data. So what I can do is, if I've done that, and if I pointed it to this ID column that was in my data set, what I can do then is now add this accuracy by ID equals true. And if I run this, we now get accuracies for each of the time series in our data set. So this model ID 1 now has 4 accuracies that are being reported, 1 for each of the different IDs. So you can see you've got American Airlines, Delta Airlines, Southwest Airlines, and so on. And this is really cool. So we can put this into a table. And actually, if I group by, if I do a group by ID, actually group by dot model desk. This is really cool. So for each of these model descriptions, if you want to group on, or if you want to group by ID, so sometimes this is a little more powerful. What we can do is we can group it, and then we can kind of see which ones are doing the best and which ones are doing the worst. So if I scroll over here, I now have it grouped by, so this is American Airlines. And if I want to look at, say, what's the lowest RMSE, and looks like, okay, so this is the highest, I believe. Yeah, so the lowest here is the GP forecaster, is what it looks like here. Or wait, no, that's the highest. Sorry, that's 5 million. So we want to do this. So the lowest is deep AR. It looks like here, it looks like deep AR. Looks like down here it's deep AR, and deep AR as well here for United, for RMSE. So we'll inspect those even more. If you want to take a look at that, and that was with this table model time accuracy function. If you want to get the lowest ones, yeah, it's deep AR for all of these. Now, I will tell you this. I did run this several times. Sometimes the torch model ends up the best. In fact, one of the times, actually just before I recorded or before we hopped on this call, it was torch that was winning. So there's a little bit of variability in how these deep learning algorithms predict, but oftentimes the deep AR or the torch models might flip-flop. Okay. Next thing, we can do the same thing with confidence intervals. So this is the old way with confidence intervals. The old way is, if you want to do a grouped confidence interval, you'll do this keep data equals true. And this is still good. It's actually more conservative than if you do the localized confidence intervals. So what ends up happening here is, if I zoom in on these intervals are all identical. So it's the same kind of range because these are global estimates. But now what's available in Model Time 070 is the ability to swap out this keep data equals true for this confidence by ID. So as long as you've indicated an ID up here when you calibrated an ID column, you can then do the confidence by ID equals true, and you just swap that out with the keep data, and that's pretty much all you need to do. So you run this, and it'll actually adjust those confidence intervals. So now if I zoom in on those confidence intervals, we should see that some of them, so let me get rid of some of these ones that have a lot high variation. So you can see how some of these are smaller or larger, and that's because that confidence interval estimate is being changed, being modified based on specifically this, how it performed on this specific time series. So even though it's a global model, we're able to get local accuracy measurements and local confidence interval estimates. Okay, cool. So the next thing I want to do, I want to talk about, so now that we're kind of going through our workflow here, we've got the models out of the way. What I want to do is I want to talk about some new hyperparameter tuning capabilities. So what we're going to do here is we're actually going to work with XGBoost, which is a different algorithm. It's a machine learning algorithm, not deep learning. But what we're going to do is we're going to show you how to hyperparameter tune with this new capability that I just added in to Model Time recently. It's really slick. So let's check this out. I'm just going to make a recipe here. So I'm going to take my training data, and with the machine learning algorithms, they depend on features very heavily. So what this is doing is it's taking my training data and using it as kind of a recipe to build features off of it, primarily this timestamp feature. So we're going to do, we're going to add some steps here, time series signature. This comes from my time TK package. And what it's going to do is add a bunch of different features on here. And then we're going to remove the date column, because machine learning models, you see how this is a type of date. That's what this means here. Machine learning models, they need numeric data. So we're going to remove the date column. We're going to build features off of that date column. We're going to remove some of the features that get added. We're going to remove any features that don't have any variance to them, meaning they're constant, because they won't be helpful. And then we're going to dummy any of the predictors that are what's called nominal or categorical. So when we do that, we get a data set that now has 37 columns. And you can see that a lot of these are binary columns or numeric. They're all either integer or double. And this is our target, which is value. And then all of these features can be used to make a machine learning model off of that. So cool. Nothing new there, but that's kind of the feature engineering aspect. This is where the new stuff comes in. So I'm going to do what's called making a parameter grid. I'm just going to make a tibble, which is basically a tidy data frame. I think that's why it's called a tibble or a tidy table. But basically, it's a data frame that has the name of the argument that I want to tweak in my XGBoost algorithm. So if you go to if you do like question mark this algorithm boost tree, which is XGBoost, and this comes from the parsnip library, so it's not even a model time algorithm. And this is the advantage of model time. We can just pull these in as we need them. So we're going to do XGBoost, and I'm going to adjust this learn rate here. So you need to name it learn rate, and you just create the values that you want to apply. And what this next function does, it's called create model grid. I'm going to have my model spec be boost tree. So that's the name of this function, and it needs to be unquoted just how I have it. Then there's the engine name, which is XGBoost. So if I do question mark create model grid, you can see all of the different arguments. And later I'll show you how to use, like how to tweak the engine parameters and how to tweak, how to add some static parameters in. But basically just keep in mind, we're going to be using this boost tree. We're going to supply it all of these different learning rates. And the engine, we're going to tell it as XGBoost. And then we're going to supply this mode here, which is going to get provided to this dots. And that's going to be a static parameter that just stays constant in all of these boost trees that we make. So we're going to make all of these different models. The learning rate's going to vary, but the mode is going to stay constant as regression. So when I run this, we get this grid tibble, and you can see it's got a new column now, dot models. And if I actually look at that dot models column, see what it is, it's all of my different model specs. Now these aren't trained yet, but you can see that that learning rate parameter is being varied, and you can see all of them are regression models because we have a static parameter in here as regression. So the learning rate's changing, it's 0.01, 0.1, 0.35, and so on. So these are all of the models that we're going to be training. So the next thing we do is we have now a recipe and a parameter grid of models. So we need to kind of marry the two up, and we do that with this thing called a workflow set. It's new in tidymodels. It's this workflow set, and basically you can supply multiple preprocessors and multiple models, and what it does is it combines all of them. And if you put cross equals true, what it'll do is it'll make kind of a crossing pattern. So if I had two recipes, it would add one recipe for each model of the first recipe and one for the second. Now I only have one recipe, so it's just going to be this first recipe, but I have here what looks like 9 different models, I believe. So that's all of my different models. So this is going to make a workflow set of 9. So it basically just organizes now, and I have a combination of 9x4 of all of these workflows. And now what I can do is use my new workflow set integration with my new parallel processing. So I'm going to set up parallel processing. So all I do is I use this parallel start, and I set it to 6 cores. And what this is going to do is it's going to use all 6 of my cores. If I check out let me try something. Monitors, show the activity, show the CPU usage. Is that what I want? Okay, so I'm going to try and show some CPU usage. So now that I have it set up for 6 cores, what it should do is it should spread out my, when I run this, it should, it's telling me that it's using my parallel backend with 6 clusters, and we can see that they're all jumping up right now. So now I'm basically spreading all those computations out to all 6 of my cores. It's done in 12 seconds. And then you can see that these drop down now. And now what I'm going to do is just hit parallel stop, and that shuts off my 6 clusters. Cool. So now what we have is this model time XGBoost fit, and we've just fitted 9 different XGBoost models. Pretty sweet, huh? Okay. So next, what I'm going to do, I'm going to use some kind of, this is actually older functionality, and I teach this in my time series course, but it's something that I don't see used in a lot of people's code. So we're going to combine model time tables. So you can see here, this is my previous gluonts table. And then I also have now a new table, this model time XGBoost fit. And this is also a model time table. Well, what if I wanted to combine these 2 tables? So now we can use this combined model time tables, and now I have all my models in one. And what it did was it overwrote the model ID column. So now they're all in sequential numbers, and you can see that they've got, and you can see everything's been combined. So some of these are fits, some of these are workflows, depending on how we've created them and what we did. Now I do need to run, and you will see here that you get a warning or a message. That's because this previous one had some calibration data, so that gets wiped clean, and we just need to recalibrate. So when I run this, it'll recalibrate, and now I can get my model time accuracy. So when I run this, this is the global accuracy again, and you can see what the global accuracy is for all of these. And then we're just doing the same thing that we did before. Now I'm going to do the local accuracy. And I'm just going to slice min, and I want to see who's winning on what. You will get all of these warnings because if you see here, we've got some NAs. That's because the standard deviation is constant. So you're getting, and when we do global, so it looks like XGBoost is winning out on all of these. When we do global, And I will tell you this, Deep AR was winning some of these before. Actually, most of them, Deep AR was winning. So it just kind of depends. And then let's do the confidence by ID. So we did the accuracy by ID, and that's why you get a bunch of these warnings, because remember, when I run this section, it's doing now for every model that I have, it's doing it on all the different time series. So you can see it's 52 rows now, a different accuracy estimate for each of the different models. Okay. And then if we want to plot it, we can do, just remember the confidence by ID true. As long as we've set this model time calibrate with the ID, we're good to go. And you can see now all the visualizations. We can zoom in on them with the slider, and we can kind of see which ones are doing better or worse by toggling them on and off and so on. The next thing I want to do, so we're running a little late on time here, and I apologize. Hopefully you can kind of stay on. We're almost done. This is the fourth thing, the new baseline algorithms. And this is really important because these are simple models. And remember when I said, you get a big shift here like this, sometimes simple models work better than these kind of higher tech models. So right here, what I'm doing is what's called a median model. So this is with the window reg function, and this is actually a global modeling approach. And what we're going to do is I'm going to tell it to use a window size of 6, and it's going to take the last 6 observations that it sees in its training data. So it's going to be these last 6 observations here. And then I'm telling it in the set engine function to use this engine and to supply it this window function here to use the median function. So it's going to take the median of the last 6 observations, and it's going to report those here, and it's going to carry those through when you forecast forward. This is a strategy that mimics a rolling median. So if your organization, tends to use the last 6 months of their, and just take a moving average or a median, this is how that forecast would perform. We can do the same thing with the mean by just swapping out this function here, and you can do it with any aggregation function. So we're doing the mean here. That's the only difference here. And then we also have another function called seasonal naive. Now this is a seasonal data set, but the problem is that if you use the last 12 observations, it's a yearly, seasonal, monthly. So we're going to do a seasonal period of 12 here with seasonal naive. And that makes this model here. But this model is going to do really bad. We're going to see that. And it basically just takes the last 12 observations and carries those forward, shifts them forward in a window. So these are some baseline models. We can put them into a model time table, and you can see we've got window function 6, seasonal naive. Now, what about tuning the window function? So here's the key idea is that I know from analyzing some of these time series competitions that you can actually get a really good model if you tune for this window size, right? So think about it. We're going backwards in time. We're telling it, okay, do a median of the last 6 observations. But what if we want to do maybe 7's better, or maybe 5's better, or maybe 1's better, and just taking the most recent data point? So what we're going to do is do just what we did before, but we're going to repeat it for the window. So remember up here in the XG boost, we did kind of, before we did this parallel start and all that fun stuff, we did this parameter grid here. We're going to do the same thing now for our window regression. So what I'm going to do is I'm going to make a window size of 1 to 12. So I'm going to vary that window size. So if you look at window underscore reg, it has this window size parameter. So I have to name it window size, and that's going to be the dynamic parameter. So we're going to use this function window reg. We're going to set, if I go to my create model, so back to my create model grid, we're going to fill out some of these parameters next. So we're going to fill out the function of the model spec as my window reg. The ID is going to be, so remember, there's a static parameter that I'm passing. So that static parameter comes from here. So if I want this to be a global model, I have to provide this ID, and that's for panel data. So we have panel data, and I want it to calculate the window by ID as a grouping feature. The engine name is going to be window function. So that just comes from from here, it's going to be the window function engine, the default engine. And now I'm using this engine params. So you see up here, we had to pass a window function through the engine. So we're going to do that using it's right here, engine params. So the static params, which is this ID, that gets passed here. The engine params, if we want to change those to something static, we change them here. So we're going to put it into a list, and we're going to say window function equals the median function. Now I'm putting this is kind of the per style of anonymous function syntax. And if I run this, now we should have a window grid that has been filled out. And if I take a look at these model specs, so if I do this window grid, if I pull the models out, we can check those out. And this is cool because we have now all 12, and you can see we've got window size 1, ID is ID. The window function is getting an engine specific argument of median. The next one is so this is varying 2, 3, 4, and so on. So everything's getting filled out, and we can do baseline tuned. And what I can do is convert it to oh, whoops, I got to run this one first. Sorry. What we can do is just map the fit function. And what I'm doing is basically going through each of these now. And now I a bunch of fitted models. See how they're all fitted now? You can see the output here. And then what we can do is now compare the best. So I'm taking my, let's see, we've got our baseline tuned, which is just which is this here. So it's all of our window list here. I've just converted it to a model timetable. So that basically takes a list of models that have been fitted, and it now makes it into a nice tidy model timetable. And then what I'm going to do is I'm going to take my previous calibration table. Remember, this had the deep AR, XG boost, and everything. I'm going to filter out just a couple of IDs that were working pretty well. And I may need to actually change these up, but based on the results. But actually, yeah, let me just do this. Well, here, let's just do this. I want to see which one was doing the best up here. And it looks like 12, 13, and 10. So I want to include those in here. Just bear with me. So we've got 12, 13, 10. So I want to have 12, 13, and 10 because these are our best models here based on each of these. And I'm going to swap this out here. We'll include 1 because that's the deep AR model. That should actually be pretty decent. So we've now got the deep AR, XG boost, 12, 13, and 10. Yeah, so we've got all our best models now. And then what I'm going to do is I'm going to pipe this into combined model timetables, and I'm going to add in now my baselines. So we've got a lot of different baselines in here. And then what I can do is just calibrate all of the baselines. And once that's done, we can get the global accuracy. And now what I'm going to do is I'm going to test out and check how these first 4 models do compared to the kind of the simpler baseline models. So best versus baseline, I'm taking model time accuracy by ID. So this is going to create a lot of accuracy estimates. Remember, 1 for each of the IDs. So there's 76 of these. And then I'm going to group by ID and just filter. We'll do filter here. Let me do this. I want to see which one's the best up here. So we'll say the 71 looks pretty good. So this is window function number 8. And now what I'd have is the best models. The best versus baseline here. So we've got our, let's see. So it looks like the window function actually did the best on some of these, did even better than XGBoost. So there we go. It didn't happen each time. Sometimes the deep AR models do better, but it turns out that this window function actually beat XGBoost on some of these. Okay, and then we can check out the accuracy. So you can see for each of these how the window function stacks up. These two, the window function won, with the RMSC being the lowest on these two. Now, I'm sure if we added more features and if we added more stuff to it, we could probably beat the window function. But for now, it tells you, especially in these changing time series, a simple function just picking literally the last data point, which is it's a window function of 1. So it's just picking the last data point and kind of taking that the next 6 time steps forward. Okay. So let's make our final forecast. We're going to do a strategy here real quick by ID. I'm going to refit my models. I'm going to refit all of my models. So all of the kind of higher end models, which are IDs less than 4. And then I'm going to grab model ID 8, which is this window function here. So we're going to grab all the XGBoost, the best XGBoost, the best time series, deep AR. And here what it's doing is it's refitting them. So it's just kind of rerunning through the epochs. Should wrap up here in a second. I think there's maybe one more. Okay, it's done. And then there's the future forecast. So I'm taking my refitted data. I'm just running through. Again, I'm doing my confidence by ID. This produces just a data frame. And then what I'm going to do is I'm going to group by the ID column and do the forecast. Okay, so this is what the next 6 time steps looks like for each of these different models. And then what we can do is we can do the select best approach. So I'm going to basically split it up into the forecast data and then the actual data. So the blue line, I'm splitting this blue line out of each of these. And then I'm just selecting the best. And then I'm going to forecast that with the best. So the XGBoost, the deep AR, and the XGBoost, that's what these models are. So it's picking different ones for each. And then an alternative strategy that works really well is to take our refit tibble and just ensemble all of the best models. So we're going to ensemble all 5 of these. So what that means, I'm going to use this function called ensemble average. I'm just going to average all of them together. So this is another strategy. So instead of selecting the best by time series, what I'm doing is I'm going to first create an ensemble first. And what this is going to do is create a forecast that's kind of like the average of all 5 of those different models. And you can see it's ensemble mean 5 models. Okay, cool. So a lot of stuff that I went through here, a lot of changes. You got to see the new models in Gluon TS. You got to see some new features with the model time workflow, calibrating by ID, accuracy by ID, and the local confidence intervals. You got to see the new parameter tuning features. And you got to also see some of these global baseline algorithms and how they can be actually pretty decent compared to some of even the higher end, especially when you get these big changes in your time series. Sometimes a simpler model is a better approach. So you can test those out, and you can even hyperparameter tune them with that window size. But if you want to learn more, so if you want to become the time series expert in your organization, I have a solution for you. So if you want to take what you've done here, but you want to learn in a deeper level what's going on and how to do this for your time series problems, I definitely recommend my high performance time series course. The reasons being, there's a lot more algorithms out there, and you'll learn these algorithms on a deeper level. You'll learn kind of what knobs to turn. So like, for example, XGBoost, the learn rate. We tune that. How did I know to do the learn rate? Well, that's just from experience. I go through a lot of that in the course. So there's classical algorithms you'll learn, ARIMA ETS, some modern algorithms, Profit, some boosted algorithms, ARIMA Boost, Profit Boost. And I'll put this in the link to the course in the lesson. And I'm actually going to give you guys all 15% off today too. So if you want to check out that course, It's going to help you become an expert for your organization. You also learn feature engineering, ensembling, hyperparameter tuning with the Tune package, which is a really sophisticated package. It has more capability than my new parameter tuning. You can actually tune recipes in there, which is really cool. With my new parameter tuning stuff, it makes it a little simpler, in my opinion. But it also you can't tune recipes. You can't do some of like the more high end stuff. You'll learn time series cross validation, when to use it, how to use it, and you also learn the difference between sequential and non-sequential models. Certain models you can predict backwards and forwards. Certain ones are sequential. You can only predict forward. How do you cross validate those, making sure that you have everything set up properly. 40 hours of content plus challenges and cheat sheets. Check out that course. All right. We're done with the demo. Again, this is going to Learning Labs Pro. If you're interested in Learning Labs Pro, I'm going to put that link into the chat as well. The Learning Labs Pro is designed for people who are already familiar with R, but want to take their skills to the next level by continuously learning. So we already talked a little bit about how you do what I just did. The big question is, how do you take this information that I gave to you today, and how do you do something with it, right? So I want you to become the time series expert for your organization. I already talked a little bit about the course. It's a really good course. There's the problem that I see is there's a lot to learn to time series. So there's all sorts of different skills, and if you kind of package them up into different kind of sections, one that's really important, and I see this from the Kaggle competitions, all of the winning solutions, they have feature engineering. So you have to be really good at feature engineering specifically for time series, meaning with calendar features, with lag features, with rolling features. These are the features that will get you better results. It's much more important than using like XGBoost is having good features in your model. An ARIMA model with good features can do better than XGBoost. The next thing that's really important is modeling and experimentation. So you saw a little bit today how we do this. The key idea is you need to be able to switch and swap out a lot of different algorithms, and certain ones are going to rise to the top. You don't always want to just use profit. That is a recipe for poor performance. In fact, profit may be good on certain time series, but it may not be good on all of your time series. You may need to use XGBoost for some time series. You may need to use, support vector machine for some time series. This is how you do that. It's called model and experimentation. Then there's tuning and cross-validation. What you do is you take the best models that perform best on your data, and then you tune them. You don't tune all of them right away because tuning is a very expensive process. You don't want to do that. You don't want to waste your time. And then you're able to scale to thousands of time series. So solve that business problem that all these companies are faced with now. So I do this in my time series course. I already talked a little bit about it. You got the link in the chat. Here's some testimonials. Jonathan Regenstein, he's the head of data and quantum research at Truist. He's a good friend of mine. He's taken the course. He's only 10% through, or when he gave me this quote, he was only 10% through, and he already picked up a couple super useful new moves. He was talking about on LinkedIn the pad by time function for my time TK package. If he likes it and he gives it his stamp of approval, then that's saying something. I have a lot of respect for Jonathan. He is, a good friend of mine, but also he's really he knows R. He's an author. He's written reproducible finance with R, the book. I have it. It's really good. So, it's good. If you're a beginner and if you want to become an expert, not only in time series, but also machine learning and also shiny web apps. I didn't show any web apps today. I knew this one was going to go long because of the amount of content I had, but web apps are super important to companies. Being able to actually take the results of your analysis, package it up into a web application. That is what most companies need. They don't want just a report. How do you distribute your forecasts? You should do that through a web app. So I teach how to do that type of stuff in my in this 5-course art track. You start with the foundations. It takes about 8 weeks, And that gets you good enough to probably get any financial or any analyst job, data analyst job. Then you take these courses, and this is probably good enough to get you into that senior or that data science role. And then if you want to get into the senior data science role, that's what this is for, the web applications. That's going to wow your manager. That's going to get you results one after the other. And that's how you grow your career with this system. So all said and done, it takes probably 6 to 8 months to complete, 6 to 9 months. And what you're going to do is you're going to grow your career in the process. I'm going to give you guys all 15% off today if you like the 5-course R-Track. Here, hold on one second. I just need to copy that into... There it goes. All right. I copied it twice. So you can click either link there. But yeah, check the 5-course R-Track program out. Some of the results that it's gotten. This is Jennifer. She landed a VP of strategic analytics job. She used my business science problem framework, and she also used R Markdown. Those are taught this is taught in the 201, the business science problem framework. R Markdown is taught in the 101. You get those 2 down, you're able to complete those interviews, questions, take home tests, and provide actual products at the end they can give. For Jennifer, it wowed her future employer. So they fast-tracked an offer for her. It's not just her, but all of my students are getting good results. So you can see Masataki, he got a data science job at a top management consulting firm. I think it may have been Accenture or Deloitte. It might be Deloitte that he's working for. Z is now a data scientist with Amazon, but he was able to actually, at one of his previous roles, use my coursework to help improve patient care while reducing costs for his previous employer. Mohana, he was able to, he had awesome results. He got 3 raises in a year. So he was getting all sorts of promotions, and it's just basically because that formula, our Markdown, Shiny, doing quick research, minimum viable products, and build that, and then get business value out of it. Provide it to your organization. They get impressed. You do that several times. Before you know it, you're getting fast tracked. Herb, he was able to build Shiny apps within 3 months. Raj, he won the 2020 Shiny competition. So these are all of my students. They're all people who are doing fantastic in their careers, and they're all enjoying the business science curriculum. All right, we already talked about this. I'm giving you guys 15% off. Just use this promotion code, Learning Labs. I think if you click the links, it'll already be working. So now what I'm going to do is I'm just going to take some time and answer some questions. So hopefully there's 116 people still on. If you have any questions, put it into the Q&A. I'm just going to go through and rattle them off one by one. Okay, so anonymous attendee, any plan to do a learning lab on short time series forecasting? So I don't have any plans specifically for short time series. What I'm going to be doing is going to be showcasing the next time series on some of the ecosystem increase, like boost time, some of these other packages that people in the community are developing. I want to showcase those because I think they're very valuable. There's Bayesian, which is out there, Garch. I want to kind of show people how to use some of these tools. I also have we have a roadmap of model time, and I have some really cool things coming, more focused on some of increasing the model time ecosystem, but for doing like iterative forecasting and so on. So we have a lot already coming, and it's going to take time because some of the software I have to build and some of the software the community is building. All right, so Vish Wajyoti has asked, is there an equivalent of model time in Python? There is no panel data forecasting platforms or forecasting platforms or frameworks in Python that I'm aware of. There is SK time, which is what I teach in my Python course. I teach a little bit of SK time. And in that course, SK time is really designed for single forecasts. So very similar to like what Fable does. So Fable is really, really cool. It can scale out and do lots of single forecasts. So SK time can do that. Now you still have to write your loops and that sort of thing. And there's not as really a whole framework for kind of simplifying some of that stuff. but SK time is what I would point you to. It's not equivalent. It doesn't do panel data though. I think it's on the roadmap though eventually. Javier has asked, I know Javier. So I was just chatting with him on LinkedIn the other day. So Javier has asked, does Model Times Torch implementation still rely on PyTorch and Conda, or does it use the native Torch and R wrapping the C++ and the libtorch library? So the answer is that it actually uses gluonts and PyTorch. So I don't use the R torch. And the reason is because PyTorch, the people at gluonts are actually building the deep AR algorithm in PyTorch. So they recognize Torch is really good and they want to include it in gluonts. So they're doing the heavy lifting there. And what I do is I just leverage their dependencies. One of their dependencies is the PyTorch library. So it's not the R version, but it's really good and it's really fast. Francisco asks, folks, here is for the Q&As. Okay, so no question there. Okay, Javier then says, please disregard. Well, I'm sure other people, if you've asked that question or if somebody has missed it, Javier, then I'm glad I answered it anyways. Brian Butler, and I know Brian as well. Brian has asked, will gluonts work with AMD GPU? I don't know if it works with AMD. I think it's tied to CUDA. So I know it works with the NVIDIA CUDA, and it's dependent on MXNet. So MXNet has the CU like 92, CU 101, depending on what your software is of CUDA. You just swap out MXNet for the appropriate CUDA version, and then it should work seamlessly with GPUs. But I believe it's the NVIDIA GPUs. Anonymous attendee asks, what is GP forecaster model? So it stands for Gaussian process, but that's really as much as I understand about it, or Gaussian process. So the GP forecaster, there is, I think, a paper on it. So GP forecaster. And if I do gluon GS, so this is the GP forecaster implementation. And unfortunately, I don't see a paper. Normally, if they have a link, they'll have a link here. But it's basically this Gaussian process. That's really as much as I know. Basically, one of my students wanted me to include it, so I've added it now into the package. And it actually does do a pretty decent job. It's also a deep learning model because you can see in here the trainer has a bunch of the different, it basically uses the deep learning trainer. So it's a deep learning model that will do pretty well in certain time series. Anonymous attendee, for deep learning models, we don't need to change date to their features, month, year, and etc. So that's correct. And I teach how to do all about the gluonts integration. There needs to be a date feature and an ID feature. Those are the only two requirements. And then and a value feature. So something that you're predicting. So you don't need to change it into any features. It'll automatically take care of that for you. Anonymous, can we do hyperparameter tuning with modeltime gluonts? Yes, you can. You might not be able to do it in parallel with the parallel processing that I showed, just because I don't think you can run reticulate, which is Python, the linkage to Python. It's through reticulate. I don't think that can be multi-threaded. So you just have to, but you can hyperparameter tune. You just can't do it in parallel. Lisa asks, do you still get the variability if you set a seed? And I think you do. I've tried setting like the MXNet seed the way that they show, and it still gives me some variable results, unfortunately. I wish I could get reproducible results out of these deep learning models, but there's always something that, for whatever reason, I can't. Tomas asks, is there a way of how the models could be reproducible, i.e. setting the seed? So I this is kind of the same question. I don't, so there is a way, if you Google, so if we go here, set seed gluon TS. So we can, you can normally do it by doing this NP random seed and this MX dot random seed. But I think other people also kind of seem to have tough time getting reproducible results. So the way you would do that is you'd have to import these two libraries and reticulate, and then use NP $random $seed 7 MX $random $seed 7. And that's how you would make the seed. Whether or not it's reproducible, I don't know. Will this video be shared maybe on YouTube? So I don't know about YouTube. It's going to be going on Learning Labs Pro and also in my time series course as supplemental information. Anonymous attendee, plan to add RMSSE on model time accuracy function. If you can make a request on our GitHub for model time, but I have no plans to change the default parameters. But we can always add more parameters as needed, and you can actually modify the parameters that are used. So it gets added in if you want to use that as your accuracy function. Hasib asks, I am wondering if the forecasting results from Gluon TS are reproducible. All right, these ones in the lab, I certainly aren't, but behind me, you can see how you would do it. And you can try it out and see if they're reproducible. Matthew asks, any future plans for a learning lab vignette on ML explainability using model time algorithms? So like XGBoost, we can actually do some sort of explainability, and it's actually really cool. You can see, like if certain months or certain holidays are adding into your model. I don't have any initial plans for ML explainability, meaning it's not on the roadmap. The roadmap right now is more on adding in the algorithms and making sure and adding in some new functionality regarding how to do like iterative forecasting. But you can certainly add it as a feature request on GitHub. All right, Karthik asks, can we run the same sample in Python? If yes, what all libraries are needed for it? So you can run like the Gluon TS piece, you can run that in Python. However, it will take a lot more code, and the advantage of using model time is you can see it's only a few lines of code. So up here, when we did Gluon TS, when we did like this stuff right here, I mean, it's just a few lines of code here, but in Python, it's probably going to take you 100 or 200 lines because you're going to have to format the data appropriately. You're going to have to get it into the Gluon list data set format, and it is very challenging. So you can, but is it worth your time? That's the question I would ask. Christian, he asks, can we piecemeal the courses instead of bundle? Yes, you can purchase them all individually. Each course is available individually. And for example, the time series course, if you're just interested in that component, you can purchase that and you can join it. Now, the one thing I will say is a lot of these courses have prerequisites. So like the 203, the time series, the prerequisite is the 101, which is the R for business. So, it's up to you whether or not you want to skip that. I can't control you, but if you're a beginner, for example, the time series course may be a little bit much for you. And I would recommend taking the 101 course first. So you maybe want to buy the 101 and the 203 course if you want to do, beginner time series. All right, Daniel asks, how can I apply lags diffs by ID using a recipe step? You can't. I mean, you can, but the recipe isn't the way that I do it. When we globally model, I have other functions that I use for those. And Daniel, I teach those in my time series course. So when you get to feature engineering with lags and differencing, I have a whole section on that. Brian asks, briefly, can you address why the accuracy metrics used in your demo applies to such a wide variety of algorithms? Aren't many accuracy metrics relative to the algorithm in question? My guess is that I think you put a regression engine behind most of the models. So yeah, Brian, this is a good question. When it turns out when we're forecasting, so there's any of the regression metrics will apply. Now, these are not like certain algorithms will use like AUC for classification. That's area under the curve. That would not apply, but all of the metrics that I've selected in the default. So if you look at, if you do question mark default forecast accuracy metric set, it's kind of a mouthful, but this is the forecast accuracy metric set, and it comes with these accuracies. Those are always reported. So these ones will always work for forecasting as long as you have 2 or more data points. Some of them won't apply if you have 1 data point, but that's what are the default, and they will work. Anonymous asks, will the newer methods be added to the coursework of the advanced time series course? So this recording is going to go into the high performance time series course as supplemental information. Anonymous asks, first of all, thanks for this great presentation. My question is, what is your approach to overfitting that might happen due to the hyperparameter tuning? So I always do hyperparameter tuning with a test set, or actually with a cross-validation set. So depending on if it's a sequential model, you'll need to, and I cover this in the course, I have a whole section on hyperparameter tuning with both sequential models and non-sequential models. Sequential models, they all need to have the time series respected. Non-sequential models actually perform better when you randomize it, meaning that the time series is not, the time aspect is not respected. So yeah, that's how I handle it. Take the course. Module 13 is 3 hours on hyperparameter tuning. It's really good. Karthik asks, I'm a Python ML developer. Do I need to learn R also, as we have nice features like model time? So Karthik, I'm a fan of knowing both R and Python. And here's why. Python's really good. It's got amazing libraries. R also has amazing libraries. A lot of times you get that, when you ask that question, and when you see something like model time and you're saying, oh, I'm a Python developer, I can't use Python or I can't use R. That's where the issue comes in. You need to be able to use, in my opinion, both, and you can actually pull one into the other. So model time can be pulled into Python using a package called rpy2, but you still need to know a little bit of R in order to be able to have that happen. So, my thought process is learn it all. We should, it used to be like, hey, just pick one and then you're good. But like with Reticulate, like I'm learning Python. I know Python now pretty well. I'm feeling, pretty good with it. I can do stuff with Reticulate. I can do stuff with rpy2. It's great. It really kind of relieves you from the handcuffs of just knowing one language. And then even down the road, I plan on learning Julia as well, which is something that I have on my radar. Ashwin asks, can these models handle multiple time series predictors, for example, COVID cases as an additional predictor? So I don't have the deep AR, or I don't have any of the gluonts models set up for regressors. But when we saw over here in the new features, when we did the XGBoost model, that used regressors. So that used all sorts of time series features and so on. You can add events to it. So the answer is, for the gluonts models, I don't have that yet set up for external regressors. But for all of the machine learning algorithms, I teach that in my course, how to use external regressors, like events, like lags, like rolling features, all the things that get really good results. Christian says, awesome, not beginner. Yes, this is not a beginner tutorial, but I will say this, there's a lot of power. So if you learn this stuff, even if you are a beginner, you will get really good. All right, so that's it for the questions. I'm gonna check out of here, but thank you so much for tuning in, and I really appreciate for those of all who stuck around. Have a great day, and I'll see you again in 2 weeks, and we'll do another tutorial on either Python or R. So I'm looking forward to it. Learning Lab 61 coming up.